Welcome to this explainer. I am so thrilled you're here today because we are diving into something absolutely fascinating. We're going to explore the nuts and bolts of building a complete hybrid solar power system from start to finish. And we're doing this through a pretty unique lens, a short, simple 3D cartoon animation script that was actually designed for an AI video generator. Imagine a colorful, really clean, high-quality animation featuring this friendly solar technician who guides us through all this modern solar energy tech. By following his step-by-step journey, we're going to demystify what can honestly feel like a really complex engineering process. So, let's jump right in.
Here is our quick roadmap for today. First, planning the solar array. Second, panels and DC protection. Third, battery and AC distribution. Fourth, backup systems and testing. And finally, powering up and monitoring.
Section 1. Planning the solar array, setting the foundation for maximum sunlight.
So our 3D animated journey kicks off with a site inspection. Picture this, our friendly technician is standing on the property, using a tablet to scan the roof. In the animation, a 3D sun arcs across the sky, casting these dynamic shadows from nearby trees and buildings. It perfectly visualizes exactly what happens in the real world, right? You have to inspect the roof to find the absolute best location for maximum sunlight. Then we move on to the math. Imagine floating 3D numbers just popping up above the solar panels. The technician is virtually connecting these panels in a mix of series and parallel configurations. We calculate these strings to make sure the voltage and current output matches our equipment perfectly.
Now, you might be wondering, why does that matching matter so much? Well, it all comes down to the MPPT range. MPPT stands for Maximum Power Point Tracking. Essentially, your solar inverter has specific voltage and current limits that it can accept in order to operate at its absolute peak efficiency. If you wire your panels together, creating those strings we just talked about, and their combined output falls outside of this MPPT range, you are literally leaving free solar energy on the table. Or worse, you're risking damage to the system. So matching these numbers perfectly ensures we maximize our solar energy extraction right from the very beginning.
Section 2. Panels and DC protection. Harnessing and securing solar energy.
All right, moving into the physical installation. It's actually a really satisfying visual. The solar panels just automatically snap right onto the mounting structure on the roof. They're locked down tight. But, securing them physically is only half the job. The technician then connects them up using proper direct current, or DC cables, utilizing standard MC4 connectors. These are weatherproof, super heavy-duty connectors designed specifically to handle the high DC voltage coming straight off those sun-soaked panels.
But a solar system actually requires two totally different layers of protection. First up is the DC combiner box. In our animation, we see these cables traveling from the roof straight into this 3D box. Because this energy is raw, direct current coming directly from the sun, it houses specialized gear, DC fuses, isolators, breakers, and surge protection devices, or SPDs, to guard against things like lightning strikes, plus, of course, proper grounding. We'll deal with the AC side of the house in just a second.
Section 3. Battery and AC distribution, storing energy and wiring the home.
Now we introduce a seriously massive piece of hardware, a 16 kilowatt-hour LiFePO₄ battery. That stands for lithium iron phosphate, by the way, which is an incredibly stable and long-lasting chemistry. The technician connects this giant battery bank to the system, and you'd see these glowing animated cables showing the energy flowing. This battery is absolutely vital because it acts as a massive reservoir. It safely stores all that excess solar energy you generate during peak afternoon sun, meaning you can use it to run your home long after the sun has actually gone down.
But how do the panels and the battery actually talk to the rest of the house? Enter the DEYE hybrid inverter. This device is basically the brain and the central hub of our entire setup. Its main job is converting the DC power, both from the roof panels and the battery bank, into alternating current, or AC power. And that's what your TV, your refrigerator, and your lights actually run on. The technician configures the communication cables between the battery and this DEYE inverter so they operate in absolute perfect sync.
This really perfectly illustrates the dividing line in our system. We have the DC side, that's the panels and the battery, dealing in direct current, and then we have the AC side. In the animation, our camera moves inside a 3D electrical distribution board. Now we're wiring the home. We're taking that converted AC power from the inverter and distributing it. Over on this AC side, we install MCBs, miniature circuit breakers, along with RCD protection to prevent electric shocks, some more surge protectors, and isolators. This just ensures the AC power safely connects to the main distribution system and your critical backup loads.
Section 4. Backup systems and testing, ensuring reliability and safety. Okay, it's the question literally every homeowner asks when investing in solar. What happens when the grid actually goes down? This is visualized so beautifully in the animation. A cartoon lightning bolt strikes the grid symbol and the main city power shuts off completely. It's this dramatic moment. Your neighbors are plunged into total darkness. But what about our house?
Well, the lights inside our house stay on, and that is all thanks to the ATS, or automatic transfer switch. When that cartoon grid goes down, the ATS detects the loss of main power in a matter of milliseconds. It automatically and instantly switches your home's selected critical loads, like your fridge, the lights, maybe your internet router, directly over to that massive battery backup we installed a minute ago. You honestly wouldn't even have time to blink before the house is safely running on stored solar power.
But, before we can actually experience that magic in real life, we have to test everything. You never just flip the switch and hope for the best. Our cartoon technician has to run through a really rigorous commissioning checklist. Using a digital meter, they meticulously check the polarity, verify all the voltages are within range, inspect the physical connections, test the grounding for safety, and confirm every single isolator and breaker is doing its job. In a 3D animation, you get these really satisfying green check marks popping up over the solar panels, the inverter, the battery, and the electrical board as each test passes.
Section 5. Powering up and monitoring, bringing the smart home to life.
This is the crescendo of the whole installation. The technician presses the power button on the DEYE inverter. Instantly, the inverter's interface just lights up. Through the magic of the animation, we see this glowing energy flowing from the sun down into the panels, racing through the cables to the inverter, charging up the battery, and ultimately lighting up the house. The system is officially alive. Clean, renewable, solar energy is now independently supplying the home.
But the modern solar experience doesn't just end in the utility room, right? It lives right in your pocket. We see our technician holding a smartphone displaying this simple, elegant monitoring dashboard. Through the app, the homeowner gets real-time visibility into absolutely everything. They can see exactly how much power the solar panels are producing right at that second, what the battery's charge percentage is, how much energy the home is actively consuming, and if they're drawing any residual power from the grid. It takes energy consumption from a total mystery and turns it into a beautifully managed, data-driven process.
We wrap up our animated script with this beautiful, wide, cinematic shot of the completed house. The solar panels are just gleaming in the sunlight. The battery and inverter are sitting quietly in a spotless technical room, with energy flowing smoothly and efficiently through the whole system.
And as the animation fades out, this powerful text appears: solar energy, smart power, clean future. I mean, it's a perfect summary of what we've just built. A complete hybrid system that's designed, installed, protected, and fully tested.
Which leaves us with this final thought. We just walked through a highly technical engineering process from MPPT ranges to AC distribution and ATS backups, and it was actually incredibly easy to grasp, wasn't it? As AI video generators make it this easy to visualize, understand, and really demystify clean energy technology, it begs the question, how soon will you take the step toward your own ultimate energy independence? Thank you so much for joining me today for this explainer. I really hope this sparked your curiosity and illuminated the path to a smarter, cleaner future.